Hello. Yeah. So next, we have an exciting story: migration from VMs to Kubernetes by Ajay A. So Ajay is a seasoned site reliability engineer at Media.net. So Ajay will be sharing his first-hand experience of migrating JARs on VMs to Kubernetes clusters. So Ajay, the stage is open for you.
Hi everyone. Thank you for coming to the talk. This talk is majorly about a story from migrating to a legacy setup, from a legacy setup to Kubernetes, and things that we faced after moving to Kubernetes. About me, I am site reliability engineer at Media.net. We take care of production infra issues and also take care of development with internal developer platform which helps developers to deploy or stage their things faster. Yeah. So who are we? What do we do? Media.net. It's a contextual ad tech business, and I'm part of ad exchange team, which basically is a bidding platform for all the advertisements that come to us. So talking about the generic legacy setup, what usually we have is a monolithic web server running in all the VMs with your metric agent or your discovery agents running. We had close to like 500 backend servers running in multiple zones, even in multiple data centers, be it on-prem or on cloud. We had our reverse proxies as HEproxy or EngineX with console to discover the backends, and then you will require your monitoring stack as metric beat and Grafana. Puppet was used for managing the configuration on the VMs. So what were the issues with the legacy setup that we had? So whenever we have a legacy setup, we have our in-house tools that are responsible for doing the deployments and doing the verification. How would you do it? Basically, get your running backend IPs, try SSH, remove or replace the replace the jar probably with the new tag, and do a verification on the URI path where you will get the latest tag for your backend applications. You might probably miss few things here and there. With this setup, it was difficult to maintain the SLAs, SLOs, because whenever there was any issue, any downtime, it used to be longer than expected because of the limited observability. Then it was time consuming to deploy, and because you will be probably doing SSH in all the VMs step by step or in batches, but it will take a lot of time. And if it fails, SREs would have to be there in order to like intervene and make it go completely 100%. Onboarding new service would also be an hassle. You will have to like write things from the scratch probably for that application with all the monitoring stack that you require for your application. So we went on a path, and we wanted to like, how can we reduce all these hassles, and even the whole community was doing it at that point of time. So you will go probably on search for an orchestration tool that does all these things for you seamlessly. What all would we want is have a ease to deploy without any intervention. Infra should be auto-scalable, especially your backend, wherever your business applications are running. You would always want auto discovery, or rather than using a third-party tool in order to rely on the discovery. It would be good if you have a auto healing setup. So let's say if your application has crashed, it should auto restart kind of thingy. So health check would be nice to have in order to achieve that. And obviously high availability has to be there so that you are always serving, and 24/7 you can achieve your SLOs. So at that point of time, one of our teams was running Mesos DCOS, and it is a containerized environment. There's a master, and everything else is a slave around it. which are running. So your master is basically responsible for managing all your slaves that running your containers, and in them it is responsible for running whichever application you want to run. It has one issue is like if your master, you have just one master, if it goes down, you won't be able to scale it, you won't be able to deploy new things, but your slaves would be still intact, just that you will have to bring up your master in order to take any action in the workloads that are running behind it. The second thing we were trying to explore is Nomad. Nomad relies on console, so we already had one part of it there. So one of my colleagues explored Nomad, but it had like multiple components that you will have to manage, and they were not like the community was also very small and like at very early stages of it. Then we also Kubernetes was also booming at that point of time. We found out that it has a really steep learning curve because there are a lot of components, and it is kind of an operating system in itself if you think it. For your cloud or for your legacy setup. It had one advantage is like your clouds started onboarding it and providing it as a service, so you don't have to manage your Kubernetes cluster. That was very like helpful because you don't want to solve problems or maintain stacks that are already managed with your cloud. The third thing was that the community was really growing with it. A lot of open source tools were there at that point of time that could help you manage your infrastructure. So we went with Kubernetes. Kubernetes has deployment, so tick mark for ease of deployment. It has a horizontal pod autoscaler, autoscaling done. Kubernetes services do your auto discovery of your backend services, backend pods which are coming up and down. Tick mark for that. It has readiness, liveness, and now even startup ropes are there, which basically helps your containers or pods to like restart if anything goes wrong or the health check is failing. So auto healing came into picture. Then high availability is achieved by your replica sets. So it makes sure that how much workloads, let's say you want 50 backend services running for your app A, so it will make sure that 50 of them are running healthy. Check for high availability. It also has ease of onboarding new application. You just need to write your deployments, services, ingress, config map, and you would be done with it. And it has like access management that we can talk about. So how would it look like once you have onboarded it to Kubernetes? You will have first your ingress. Let's say I'm going with an example.com. I have one backend service running behind it, and it is accessible through example.com. So you will have your Ingress, which probably would rely on Ingress controllers of your choice. You want EngineX, get it. You want anything else, you have freedom to do so. Your Ingress will then route it. It will not route it, but it will get the information from Kubernetes service to. You will point basically the configuration to your Kubernetes service, and it will figure out all the pods that are running behind it. Kubernetes service has a subcomponent that is your endpoint slices. So it's not like your Kubernetes service will become a bottleneck at one point of time due to your high workload. Let's say if you are running 10,000 pods, things can become complicated at that point of time. So endpoint slices would take care of it by splitting all the grouping all the pods in some manner and marking that inside Kubernetes service. So your ingress basically will reach out to all your backend pods. Your backend pods. So if application A is running, they all will be having similar configuration. They would need to rely on, and you can rely to place that configuration outside your container. You can place it in config map. So if you have different data centers, you can rely on your config map and keep your application generic throughout. How those pods will be there is like a replica set will make sure how many pods you need, but replica set is managed by deployments. You can see on the top right second mark. So deployments basically make sure that whatever workload you want to run, it will run. Deployments do have replica count, but if you want autoscaling infrastructure, you would deploy your HPA, horizontal pod autoscaler, which will get some information like your matrices or CPU utilization, whatever you want your application or your workload to scale on. And it will basically scale up and down based on that metric. So we moved to Kubernetes after gradually testing things, bringing up a parallel setup with Kubernetes, because you cannot directly move things, especially when it comes to production, which is running quite well for business point of view. But from SRE point of view, you will be having a lot of on calls and things around that, which you want to get rid of, your ad hoc operational tasks that come redundantly, your deployment issues and things around that. So you would basically set up a parallel setup and compare the matrices, showcase it to your senior management, and then you will also try to onboard all your SREs, all your dev teams to be aware of all the features and all the things that you will be relying on in future. So with Kubernetes, you have a lot of YAMLs, which you mostly would be putting in a Git repo. Then you will have multiple data centers, but how would you apply those YAMLs? You can basically do a kubectl create or kubectl apply and write the file names, but that would be a very that would become a hassle after one point of time. You probably can use a script around it, but what if someone made a commit but the script did not run or the configuration is not applied in the cluster? What would you do? Go and try kubectl diff? How many times will you do it? That would become a problem at one point of time. So to solve this problem, we explored in the open source community CNCF projects that were around, and we found out one suitable candidate for us to do a continuous delivery for us, and that was Argo CD. So what Argo CD does is it links, or it basically pings your GitHub repo, let's say 5 seconds, and it is configurable. So it checks if there are any changes in your repo. It creates an application, or in case of multiple data center, you can create an application set which will create multiple apps for each data center, and then you can rely on it. It will show you the differences if there are any YAML changes. You can also configure it to auto sync it. So let's say if you have merged some changes to your master and you want all the changes to be auto deployed, you can tick mark a auto sync option that is present over there. So it will by default sync all the changes. You can stop it from deleting resources. So if your auto sync is on, you don't want, if someone accidentally removes some resource that you don't want, so it has a capability of like stopping that as well. So everything is quite configurable with Argo CD, and it helped us a lot in managing multiple data center with just one UI. So after we moved to Kubernetes, deployments were good, shining and rising. So, but one point of time, developers came to us. They wanted to do a deployment which was DB critical. Like there were some database changes that they were doing, and they wanted like all the backend applications to be switched to the new tag at the same time. They did not want any older tag to be running, because that could break production or break some percentage of the business at that point of time. So they wanted to like deploy things in a blue-green fashion. So that was our solution, but the default Kubernetes deployment does not support such things. And let's say they wanted to like deploy, so deployment, you would want to like do a canary deployment at that point of time as well. So for those things, we relied on Argo Rollouts. That is again a project by Argo project community. So what it provides is you can have your blue-green deployment strategies as well as your canary with some percentage control. You can pause the canary to let's say 5%, and you can like auto promote it with 5-minute configuration. So it is quite configurable, and it helped us to tackle all the issues regarding deployments. Then at one point of time, you would want your applications to your application would have different dependencies, different workload requirements based on, like, if your traffic is surging, you would rely on some custom metric so that your average pod QPS remains same, and that is generated by your application, which is sitting, the metric itself is sitting inside Prometheus, and you would want to like rely on that for your HPA to judge if it needs to scale up or scale down. That can be your messaging queue metric. So if you want to like do auto scaling beforehand, you would try to point it to things that are sitting before your deployment. So there are many custom use cases that were coming to us, and then we had to find a way how can we upgrade our HPA so that it can scale up based on any system that is sitting outside or inside Kubernetes. So kada came into picture for that. It can integrate your Prometheus, your queuing matrices, and anything that you would think of, and it will create a scaled object. It basically creates a scaled object which is responsible for creating your horizontal pod autoscaler resources, and it directly links your Prometheus matrices. Like for us, it was doing it, and then we were directly using it to like scale up our production based on any custom metric that developers wanted to use. So what other issues we faced at let's say at one point of time, one of the SREs was trying to do some operational task. Let's say application A was deployed in application A namespace, and he wanted to like, he was testing something out for new setups, new staging setups. So he had created application A-stage namespace and done all the things in it. And then he was like distracted, and when he was cleaning up the application A-stage namespace, he accidentally forgot to append the -stage namespace, and it actually did some issue. So how would you tackle those issues? That also requires like if you give freedom to your developers to create their own YAMLs for your deployments and all, they would probably miss adding labels, probably miss adding your CPU requirements or memory requirements, right? So we faced this issue, and we again went to CNCF community and found out one great tool, that was KRONO. So what KRONO does is it sits between your API servers of Kubernetes cluster and whatever you are trying to do with your kubectl. So you can configure policies around it. If it checks for the policy or for the action that you are going to take, if it matches to the policies that it is configured with. So let's say if I want to delete some resource and that has label, let's say service internal, then it will allow me to delete. And if it has service equal to external, and I have configured the policy around it, it will stop the call itself to go to API server, and that will probably prevent the disaster to happen. So that was a great help for us. We were running good for more than 1 year and so, and our production started growing at a very large scale. So we faced issues around that, even though Kubernetes is very scalable, but we had different kinds of issues that we were seeing at that point of time. So one evening, we got to know that there are some timeouts happening in the evening, and me and my manager and everyone was sitting there, and we were trying to figure out what happened wrong. So we saw that the pods were not scaling up. So what we did was we tried to manually scale the deployment. Still the pods did not come up. We tried to increase the node count. The nodes were not coming out. And this was all happening on a cloud. So I just randomly tried to create a node pool, and then I get to know like there was an error throwing that you are running out of your subnet, like the subnet is not sufficient. So this thing can happen to any of us. What we basically need to take care of is like how many IPs you are reserving, or how many pods you are planning to run on your each node. So what happened to us was, by default, the value was 64 per node, while we were running just 10 pods per node. So what the cloud was doing is it was reserving 64 IPs for an individual node, while we just were using 10. So rest of them were getting wasted, and we ended up at one point where all the IPs were exhausted. So we then tuned all the pod counts for each node, and that basically fixed us. And as backup, we created different subnet and created node pools around it to prevent it from happening ever again. Next day, not next day, but such similar evening, one of the product manager reached out to us. Evening was the time when all the traffic used to increase. So one of the product manager reached out to us and saying that the business matrices are not looking good. Like they are like slightly lesser than what we expect to. And we then again sit on troubleshooting, finding out what is happening wrong. So we get to saw like our autoscaling was working fine. Traffic was like, there was no alerts, nothing out of the ordinary. Just one thing, that our CPU utilizations were higher than usual. What could you do? You would expect your HPA to scale that up, right? And it was doing so, but the speed at which the pods were coming up was lesser than the speed the traffic was surging. So what was happening is that the traffic was increasing at a much higher rate, while the pods were not able to like catch up. The scale or the count of the pods are not able to catch up to that. So what we went is like we discussed with the developers like what can we do in order to. We needed some metric which can be reactive enough to tell us that our workloads are under pressure or some kind of that. Little's law helps us in these scenarios to figure out how and when you should be scaling up related to what matrices you can rely on. We found out that we were running, we are autoscaling based on QPM and CPU, which was not that reactive to the surge of the traffic. And post some discussions and some research, we got to know like concurrency can help us in order to defeat this issue, because concurrency basically ramps up whenever there are more requests to individual pods. So we relied on concurrency, and we basically had a very reactive autoscaling post that. So we never faced that issue again. Cool. So when you have large workloads, you have a lot of matrices, and with Kubernetes and the ease of onboarding matrices tools, it becomes really out of control. It goes out of control that you have so many matrices and your Prometheus will start crying at one point of time. So we started with 300 GBs with 300 GBs of memory with one of the Prometheus in one of the data center, which was the biggest. We started vertically scaling it to the point where we were running 800 GBs of a single Prometheus server, which if it goes down, it takes like at least 30 minutes or so in order to come up. So what would we do at that point of time? We researched in the community, found out that Thanos was there, which was targeting this problem. So what we wanted was to have a horizontal autoscaling of Prometheus. And what Thanos does is it relies on Prometheus operator to bring up small Prometheus servers, and has its own query and on components on top of it to aggregate all the things around it. So one time I was discussing with one of our tech leads who manages the backend application. So he informed me that he was seeing sudden traffic bombardment on the application whenever they were scaling up. So we were, let's say, running 16 cores per workload, per pod basically. So whenever a new pod would come up, they were suddenly bombarded from 0 to, let's say, 300 QPS suddenly. And they were running Java, so Java does lazy loading. What lazy loading would impact is basically it will slow down your request in the initial duration, because it will tend to like time out very frequently, especially in the initial timeout. So what we wanted was to have something like which would buffer our workloads rather than bursting the traffic of 300 QPS. If it can like gradually increase up to 300 QPS, we would be wasting less requests and dealing with the problem. Again, when you have autoscaling infra, this thing would happen now and then every day. The third thing which we found out is like we were seeing our discovery of pods with console was slightly delayed, like 30 seconds or so. So our EngineX or load balancer was getting or sending the traffic after 30 seconds or so. And we like when we are investigating this issue, we also got to know this. Then there is one issue with EngineX is that it does not support HTTP2 with the upstreams, but our workloads are ready to accept HTTP2 requests. The last thing was that we had a business requirement where for each request, we wanted to set a dynamic timeout for the client. So if we are getting a request, let's say so each request had a value in it for which we have to respond, in which time we have to respond back. So if backends are not able to respond back, we have to do it on the load balancer itself, so that we are not sending bad responses or the client is not timing out before us. So, and that is not supported by EngineX. You cannot configure default dynamic timeouts for each request. That is very typical thing too. Then again, did some research, found out that Envoy was getting a lot of attention. We got to research and we saw that why it was getting so much attention. It had a lot of EngineX was built at a time where cloud was not that mature, and we are still using that technology, and it works for most of us. But when you go and drill down, you would want a lot of things can be done with the load balancer part. So Envoy had a built-in feature that is slow start. What it will do is you have to configure your backends with a load balancing policy of least connection, and you can give it a number, let's say 120 seconds. So it will increase the traffic from 0 to 300 QPS in span of 120 seconds in an exponential, not sure. Yeah, so it scaled up and that solved our problem. The second thing which Envoy, actually this is the primary thing which Envoy provides is your XDS, support to XDS, which is X stands for any component and discovery service. So let's say it has listener discovery service. Listener stands for, let's say, your downstream connection, downstream configuration. If you want to inject, you can inject it via listener discovery service. You want to inject your routing config, it has RDS for that, route discovery service. If you want to inject your upstream configuration, that would come under cluster, and it has cluster discovery service. So you can inject all these configurations separately while your Envoy is running, let's say, on VM or anywhere. And you can inject the configuration from sitting inside Kubernetes also. So basically how it helps is to separate out the control plane, which can sit outside your load balancer, and your load balancer just had to, load balancer will basically act as a data plane at that point of time. Also, Envoy has support for built-in matrices that are really good. It readily can help you to enable traces, and has built-in rate limiter, which we haven't used yet. It also has dynamic timeout support, which can be configured by configuring some of the data, some of the headers which it has that are present in its documentation. So what we basically did was used Lua to read the request body, get the value out of it, and directly set the header. And that basically dynamically changed the timeouts for individual requests in real time. But what we wanted was to have a control plane, and either we can build our own control plane which will get all the workload IPs, generate the config which we want in our load balancers to run, and inject it. But again, why reinvent the wheel when you have such a big community which is already trying to solve these problems? So we came across Istio. Istio was majorly popular for service mesh at that point of time, even it is now. So it was relying on Envoy proxy underneath. They had built their own control plane, which was basically injecting all the configurations in the sidecar that was Envoy, and it was getting the configurations in the Kubernetes YAML format. So you configure, you kubectl apply your configuration, and Istio will parse it to your Envoy, and that was the feature we were looking for. But for us, we wanted to use it as a reverse proxy, not as a sidecar. Yeah. So, cool. Where was I? Great. So we wanted to use it as edge proxy. We did not want it to run as sidecar proxy, sidecar, right? So what Istio has is virtual services, which basically manages your routes. So let's say if I have application A running in under a service A, I can have virtual services around it. And if my service is having, my Kubernetes service is having multiple versions of the application running or discovered behind it, you can basically split them in the Istio virtual service to have a different percentage of traffic that they can serve. You can tune it very easily. Then you have to configure a destination rule. What destination rule basically would do is, it basically will add your routing paths. So let's say if you want to route your /abc to some workload and /xyz to some other workload, you can do it. And in order to, so we configured Istio VM in one of our VM. So that basically installed Envoy, and we connected it with the Istio-D. So Istio-D was injecting all the configurations, but we wanted to run it as router. There was a filter, there was a configuration that can be used for that. So eventually this is how it looked like. We had Istio VMs that are running Envoy. These are considered as workloads. Workloads, you can relate it to like pods, and there was a workload group for which all the configurations was applied for based on the selectors. The gateway is basically a router mode of Istio that basically configures the Istio or Envoy in the router fashion. Your Istio-D pods were running inside the cluster, which can discover all the changes that are happening to your Kubernetes services, all the events, pods coming and going, and generating the configuration in live fashion and injecting it to all our Envoy proxies. So yeah, that is it. Thank you for being a good audience. Yeah.
Thanks for that very insightful talk. We'll have a very quick round of questions. Are there any questions? Okay, there are none. You can connect with them offline as well after the talk. So
Cool. Thank you.
thank you so much.